So this is October 2025, Unit 2 paper. Question number 1 says, what color is the solution that forms when iodine dissolves in a hydrocarbon solvent? Remember, you need to memorize some sort of, you can say, the colors of iodine, what's the color of iodine in organic solvent? That's that they are saying hydrocarbon solvent. It's like hexane. And of course, they have given you some color, so it's going to be purple in color. Whenever iodine is dissolved in hydrocarbon solvent, so it's purple in color. Y A is incorrect, YB is incorrect, YD is incorrect. So means that you must know whenever the solution is brown. So it's mean that iodine is dissolved in Ki. Iodine is dissolved in Ki. So then it's going to be brown in color. But in the question, what they are saying iodine dissolves in a hydrocarbon solvent. So purely it's about memorization. It's purely about memorization, remember. So you are supposed to memorize some colors, okay? Then question number 2, which row shows the correct trends down the group 2? Okay, so reactivity increases down the group because size of group 2 element increases. Outer electron gets further away from the nucleus. It's having a weak nuclear attraction, so it can lose its electron easily. So as we go down the group, reactivity will increase, right? Because metals have a tendency to lose electron. If the metal will lose electron easily, so it's going to be more reactive. And if the metal is not going to lose its electron easily, so the metal is less reactive. So it's mean that increases. We have two options, A and B, or solubility of hydroxide. So in your specification, according to the syllabus, you only need to know about the solubility of group 2 hydroxide and the solubility of group 2 sulfate. So solubility of hydroxide increases and the solubility of sulfate decreases. So it's mean that A is correct. Again, if you know, so you will do the question. If you don't know, so you are not supposed, like you will not be able to do the question. Like let's say if I see this question in an exam, so I would think, like, do I know the trend of solubility of group 2 hydroxide? If yes, okay. Do I know the solubility of group 2 sulfates? Yes, I know it decreases. Okay. So decreases and increases. So it's mean that there is only one option, decrease, increase. So this is wrong. This is correct. Okay, it may be C as well, but then it would justify like the reactivity of element. Since we know reactivity of element increases down the group, so it's mean that A for apple is correct. Okay. Or they are saying the gas nitrogen dioxide exists in equilibrium with another gas, dinitrogen tetroxide. What happens to the color of the equilibrium mixture when a catalyst, remember, what's the job of catalyst? It only increases the rate of reaction. It would not change the direction of equilibrium. Remember, the catalyst would not be able to move the reaction to the forward direction or to the backward direction. Why? Because the job of the catalyst is to change the rate of reaction, and that's it. And that's it. So what would be the color? Of course, it's brown and it's colorless. And in an equilibrium, the rate of forward reaction is equal to the rate of backward reaction. I would say no change. Because catalyst is not going to do anything. Okay, what we have discussed, who will change the position of equilibrium? Concentration, temperature, pressure, volume, but not catalyst. Remember, which isomer has the lowest boiling temperature? Okay, so we have discussed in chemical bonding, it depends on the IMF. IMF depends on the two factors, number of electron and the surface area. If the surface area is higher, so the IMF is higher. If the IMF is higher, so the boiling point is higher. If the IMF is lower, so the boiling point is lower. So how do I do this question in a limited time? So I would say 2 comma 3 means it's a branch. 3 comma 3 it's a branch. 2 comma 2 comma 3 it's a branch. Heptane, it's not having any branch. It would be the highest when there is no any branch. So means that the surface area is higher. So now I would see in which compound there is more branching. When the branching increases, so the surface area decreases. So I would say the melting and boiling point is going to decrease. I would say option C is correct. You know why? In this compound it has 3 branches. So when again I am saying when the number of branches increases, so the surface area decreases. When the surface area decreases, so the boiling point decreases. Then question number 5, sodium chloride dissolves in water. Which diagram shows the arrangement of water molecule around a sodium ion and a chloride ion in a solution? So sodium ion, of course, it's a cation, and the size of cation is smaller than the size of an ion. So what I would say, it's going to be cat n, cat n, cat n. So it's confirmed, cat and n. Like this is an anion. Anion and cation both would attract the water molecule, but opposite charges attract each other. So we know that the water molecule has a partial negative charge on its oxygen and a partial positive charge on a hydrogen atom, right? So it's a cation. Remember, if it's a cation, so why the positive side of the water molecule is going to attract the cation? So it's wrong. So it's wrong. Yep, it's right. This is right. Why? Because the negative side of the water molecule is gonna attract with the sodium cation. Okay, and this is called chloride ion. So chloride ion means it's a negative ion. So the positive side of the water molecule is going to attract the anion. So yes, this is correct. Why C for cat is wrong. This is negative, and the negative part of the water molecule is attracting the negative side, which is impossible, which is impossible. So that's why B for ball is correct. So there is a concept behind it. You must know that the ions attract each other. Yes, but when they have opposite charges. Same charges repel each other, different charges attract each other. Okay. What is the name of the attraction between the water molecule and the sodium ion and chloride ion? Sodium ion and chloride ion. Of course, it's not hydrogen bond. It's 100%. It's not hydrogen bond. Hydrogen bond is the bond between the hydrogen and highly electronegative elements. And the highly electronegative elements are FON, FON, like fluorine, oxygen, nitrogen. So this is an ion. Sodium is an ion. So ion permanent dipole attraction. Like D for doctor is correct. Okay, it's an ion permanent dipole interaction. So D for doctor is correct. Sir, how do you know? Sir, how do you know? Sir, how do you know D is correct? Why not A? Why not B? Of course, C is not correct, right? Instantaneous dipole. Remember, they are talking about H2O and Na plus. It's having a permanent dipole, isn't it? It's a polar molecule. It's a polar molecule. It's having a permanent dipole. When it's having a permanent dipole, so I would take an option in which I can see permanent dipole, permanent dipole. So why not B is correct? Because we have a one molecule which is having a permanent dipole. And another thing is that we have only an ion. It's not a compound. It's not having permanent dipole. It's an ion. So I would say D is correct. Like it's a force of attraction between the ion and a permanent dipole. Like I'm talking about the water molecule, okay? And which line on the sketch graph best shows the trend in boiling temperature for the hydrides of elements in group 6? Group 6, it starts from, I would say, okay. Group 6 means it's having oxygen, right? Group 6 means, oh my God. Group 6 means it's having oxygen. Let me see the periodic table. Okay. So if I see group 6, this is going to be group 6, right? Oxygen, sulfur, selenium, tellurium, polonium. Okay, 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 okay. So what they are asking, They are saying that which line on the sketch graph best shows the trend in boiling temperature for the hydrides of elements in group 6? As we go down the group, as we go down the group. So, I would say that electronegativity of oxygen, of course, the number of electrons also matters. And hydride means, hydride means like H2O. And then after oxygen, we have, I think so, after oxygen, what we have? After oxygen, what we have? I can say sulfur. So if I talk about sulfur, it's going to be hydride of sulfur, like H2S, like H2S, right? So which line on the sketch shows the trend in boiling temperature for the hydrides of elements in group 6? So means that hydride means H2O, H2S. So it's having hydrogen bonding. It's having a higher boiling temperature. H2S doesn't have hydrogen bonding. It's having a lower boiling point, right? So the boiling temperature should decrease. The boiling temperature should decrease. So P is correct because it's going to decrease. It's going to decrease. It's going to increase, which is not correct. Increase, which is not correct. Increase, which is not correct. In fact, oxygen is like that. This is going to be sulfur. Okay. And then so on. So H2O and H2S as we go down the group. So the IMF decreases, so the boiling temperature decreases. So it's going down. It's going down. So A for apple is correct. And that's it. It's very simple. Okay. So means that you must know type of IMF. Like instantaneously, you must know all the examples which are having permanent dipole, which are having hydrogen bonding, which are having temporary dipole, so that you can do the question in an easier manner. And then they are saying a mixture contains 36 gram of water and 46 gram of ethanol. What is the approximate? What is the approximate percentage of water in the mixture by moles? In the mixture by what? By moles. So how like can I solve this question? Okay. So yep. Number one. Number one, I would say, number one, I would say I'm going to have 36 gram of water. So it's going to be water. It's going to be water. It's going to be ethanol, like C2H5OH, right? So 36 grams, 46 grams. Then I have to find out the moles. I'm going to divide it with the MR of water. I'm going to divide it by the MR of ethanol. The formula for ethanol is C2H5OH. So the molecular mass is going to be 46. So the molecular mass is going to be, so the molecular mass is going to be 46. I would be getting, and then 1. I would be getting 2 and then 1. Right. Okay. So if I would be getting 2 and 1 and they are saying approximate percentage of water in a mixture, whenever we are going to find out the percentage of mixture, so I would be getting so I would say the mole of the required substance divided by the total mole multiplied by 100. I would be getting 67%. It means that A for apple is correct. And that's it. So, the concept is we used to say, can you tell me the percentage of carbon in sodium carbonate? What we used to do? Mass of carbon divided by the total mass multiplied by 100. It would give you the percentage of carbon in sodium carbonate. Right? That's the concept. That's the concept. I'm using the same concept over there. So they were asking to find out the percentage of water. So I need to know the mole of water. Then I need to know the total moles so that I can divide them and then multiply it by 100 to give you the percentage of water. Okay. Simple, easy. Or hydrogen peroxide decomposes as shown. 20 centimeter cube of 2.0 mole per dm cube H2O2 solution completely decomposes at room temperature and pressure. What volume of oxygen is produced? What volume of oxygen is produced? You know what would I do? Number one thing is that I have to find out the mole of H2O2 that is equal to concentration multiplied by volume divided by 1000. Okay, so I would be getting what? Uh, they are talking about oxygen is produced, right? Oxygen is produced. Okay, so it would give you the mole of like H2O2. So wait, let me calculate it. Let me calculate it. Oh my God, calculate. Okay, 2 into 20 divided by 1000. It's gonna be 0.04 mole of H2O2. So the mole ratio is, so the mole ratio is 1 2:1. If I have 0.04, it's going to be x. X is equal to 0.04 over 2 is going to be 0.02 mole of O2. I have to find out the volume. So the volume is equal to mole times 24.02 multiplied by 24. It's going to be 0.48. It's going to be 0.48. So means that option C is correct. Okay, simple. Again, but1 in burns in oxygen as shown in a closed system. What volume of gas remains in the system when 20 centimeter cube of but1 in burns completely in 200 centimeter cube of oxygen? Assume all volumes are measured at room temperature. So they are talking about but1 in burns this much oxygen. So what volume of gas? I have to take butane. I have to take oxygen. I have to take carbon dioxide. Why not water? Water is liquid. They're talking about gases, right? Okay. So according to the given equation, it's going to be 1. It's going to be 6. It's going to be 4. I'm copying these numbers. This is 1. This is 6. This is 4. This is 1. This is 6. This is 4. I'm copying down the number which they have given in the like equation. Okay, and then I'm going to write down the volume. For the gases, the volume considered as mole. Remember, for the gases, what I'm saying, for the gases, the volume considered as mole. The volume considered as mole. Remember, okay? So what I would do, 20 centimeter cube of but1 is going to react with 6 moles of oxygen. It means that, oh, ho, ho, ho. 6 moles of oxygen means that multiplied by 6. It's going to be 120. Like this much, this much butene needs 120 centimeter cube of oxygen so that it can completely burn. But how much I have? 200. Oh, more than the required. I have more than the required. So how much is left? I have to subtract it from 120. So I would be getting 80 centimeter. This much volume of oxygen, this much volume of oxygen will left behind after the combustion, right? And how much volume of carbon dioxide would be produced? So 20 multiplied by 40, it's going to be 80 centimeter cube. So the total is going to be 160. Answer is B for ball. It's very easy. Answer is B for ball, right? So I'm going to see the volume of the reactant. This is your base. This is your base. This is your base. Remember. So I have 20 centimeter cube of butene. So I took an idea. If I have 20 centimeter cube of butene, so to burn this much butene, how much volume of oxygen would be required? So I need to know the mole ratio. For this, they have given you equation. I saw the mole ratio. The mole ratio is 1:6. So I thought that if I have 1 mole of butene, it will require 6 mole of oxygen. So now I'm thinking if I have 60 centimeter, if I have 20 centimeter cube of butene, so how much volume of oxygen would be required? So I have to multiply this 20 by 6. So I would be getting 120. It means that I need 120 centimeter cube of oxygen so that it can be completely burned. Now I will see how much I have in the question. They have given you 200. It means that this is an excess volume. So, okay, after having 200 centimeter cube of oxygen, how much volume of oxygen will be used? So you will say 120 centimeter cube. So how much is left behind? You will say 80. So this is the volume of oxygen in the end of reaction that remains. That remains. Now I have to see, is there any other gas that remains after the reaction? Of course, the product side. I have to see how much CO2 is formed. Again, I would see the mole ratio. If I have 1 mole of butene, it would produce 4 mole of carbon dioxide. That's from the equation. Now I would see from the given data, if I have 20 centimeter cube of butene, how much CO2 will be produced? Of course, 40, like 80 centimeter cube of carbon dioxide. So means that these are the two gases which remains in the end of reaction. Number one, 80 centimeter cube of oxygen, 80 centimeter cube of CO2. I have to add the total volume of gases because they are asking what volume of gas remains in the system. So I would say total 160 centimeter cube of the gases will remain at the end of reaction. At the end of reaction, right? Okay.